Good evening, all of you, and let's see this beautiful question. So let's read the question. Two circles C1 and C2, each of unit radius have centers A1 and A2, such that their distance is 6. P be the midpoint of A1, A2, and C3 be a circle which is externally tangent to both. C1 and C2 have a common tangent that passes through P. If this tangent is also a common tangent to C, then find the radius of circle C3. So before I go further, it's better to draw a diagram. So let's start with circle C1, circle C2. We have a larger circle C3 which touches both of them. Now the center point is A1 and A2. Now let's join them and call it A1 and A2 respectively. Now we have a common tangent to C1 and C3 as shown in the figure. P is the midpoint. Let's draw perpendicular from A1 to that line, common tangent. We have radius 1. And as you can see, if I'll connect these lines, we have a right angle triangle around center A1, and the distance P times this distance is going to be, and we have this distance is going to be root 8. Okay, so now what we can do is we can clearly see this distance is root 8, and by symmetricity we have this distance is also root 8, right? Because again I can join this A2 with this center and it will be perpendicular actually. This is not very difficult, because if let's say we have two circles which is tangential to each other externally, if this radius is R1 and R2, it's a well extended fact that the length of common tangent is going to be 2 root R1 R2. This can be proved in a very simple way. Let's say if you connect the center, so this guy is going to be perpendicular. Now we know from this point if I'll draw perpendicular, so this distance is basically length of tangent. So distance between center is R1 plus R2 in this case, and this small chunk is R1 minus R2. Now just by using Pythagoras theorem, we get that distance x square equals R1 plus R2 whole square plus R1 minus R2 whole square. Right, so that gives you 4 times R1 R2, so x is 2 root R1. With this problem is done, because CD distance we know 2 root, right? In CD distance, let's say radius of C3 is R, so we have 2 root R into 1, where 1 is radius of 1. So 2 gets cancelled, and the answer for this problem is 8. So this was an easier problem, but a similar idea was already touched in JEE Advanced and JEE Mains before. Let's move to the next question. Again, as you can read the question, U be a vector and B be perpendicular vector is in xy plane. So this is U, and let's take V as one vector. In fact, we'll have infinitely many vectors, okay, which is perpendicular to U, because magnitude can be in this direction or this direction, or even magnitude can be infinitely many. But anyway, if there are n vectors Ri 1 to n in the same plane having projection of 1 into on U and B. So let's say if you have some vector called R1, so this projection on U is 1 and projection on B is 2, then we have to find the sum of the squares of magnitude of all of them. So this is again a comparatively easy question, because what we can do is without any loss of generality, I can make this U as a new axis and B as new axis. So let's rotate this entire coordinate with the angle theta, such that tan theta equals U point is 4 3 is 3 by 4. So our new diagram will be, you have new U on the new axis, coordinate 5 comma 0, and we have some B. Okay. Now we want all those vectors whose projection on U is basically 1 and projection on B is 2. So clearly one of the possibilities for vector is 1 2, and you can see other possibilities is minus 1 2. We have minus 1 minus 2 and 1 minus 2. So we have 4 such vectors, and the magnitude of each of them is root 5, so this square is going to be 5 plus 5 plus 5 plus 5, hence the answer is 20. Let's move to the next question, and this is an interesting one, a bit difficult compared with the first two. S be the set of all 7 primitive root of unity. So we have seen like there is a new wording here, primitive or root of unity, and since it's JEE Advanced question, so they must have mentioned what does it mean. Let's move further. T be the set of all 9 primitive root of unity with imaginary parts greater than 0. Now what is primitive root of unity? A primitive nth root of unity is a nth root of unity that is not a kth root of unity for any k belonging to 1 to n. So always first decode this. The comprehensive skill is very important in this kind of examination. So instead of, let's say, n, if I'll keep 9, so let's see what is primitive root of 9th root of unity. So put n9 and read the question again. A primitive 9th root of unity is a 9th root of unity that is not kth root of unity for any k belonging to 1 to 9. Now you know 9th root of unity is what? 9th root of unity will lie on a circle and it will divide circle into 9 equal parts. We have 1, let's say z, z square, z cube, z4, z5, z6, z7, z8 and z9 is 1. Now is all of them is primitive roots of unity? Clearly not, because as you can see, any 9th root of unity, the z value I can write as e I 2 pi by 9. Okay. Now is this z for any k? For example, k can be 1, 2, 3, 4, 5, 6, 7, 8 and 9. It means this z should not be first root of unity. Means root 1, of course root 1 is 1. It should not be second root of unity, that's true. It should not be third root of unity, 4th, 5th, 6th, 7, 8, 9. So yes, this z is qualifies to be primitive nth root of 9th root of unity. What about z square? Again, if we'll say z square, we'll get I 4 by 9. Now clearly, if we'll take I 4 pi by 9, it is neither first root of unity, second root of unity, third root of unity. How will you check whether it's not third root of unity? इसका power अगर हम 3 कर देंगे, e का power I pi by 9. So its power 3 is not 1. Similarly, power 4 is not 1. 5 is not 1, 6 is not 1, 7 is not 1, 8. So this again qualifies to be primitive 9th. ऐसे अब z cube को एक बार चेक करते हैं. So what is z cube? Z cube is e I to the power 2 pi by 3. Now the problem is this is not first root of unity, it's fine. Is it second root of unity? No. But is it third root of unity? Answer is yes. Because if I'll take its power 3, I'm getting 1. So z cube is not a primitive 9th root of unity. Make sense? Similarly, z4 if we'll check. So it will become e to the power I 4 pi by 9. Okay, this is z4. Now again try whether it's power 1, power 2, power 3, 4, 5, 6, 7, 8. No. So as z4 also qualifies to be primitive 9th root of unity. So comprehending problem was important. Now I'm not calculating for 5, 6, 7, 8. By symmetricity you can check. Moreover, in our question, what is set T and S? Set T is set of all 9th primitive root of unity whose imaginary part is greater than 0. इसका मतलब now we have already found set T. So set T contains Z, Z square and Z4 because these are the numbers whose imaginary part is this height and this height is strictly positive. 1 I will not consider because imaginary part is exactly 0. Now exactly in the same way I can find set S, 7th primitive root of unity. So you know it will divide number line into 7 parts. So let's call it like omega, omega square, omega cube, omega 4, omega 5, omega 6 and we have omega 7 as well. अब यहाँ से again e to the power I 2 pi by 7. तो आप चेक करो, it should not be 1 root, 2nd, 3rd, 4th, 5 and 6th root of unity. So clearly this qualifies to be primitive 7th root. What about omega square? If I will take a square e to the power I 4 pi by 7, neither is power 1, 2, 3, 4, 5, 6 is not 1. So clearly it's not even any, it qualifies to be primitive root. Similarly omega cube if I will see e to the power I 6 pi by 7. तो इसका पावर 1, 2, 3, 4, 5, 6 कुछ नहीं हो रहा है क्योंकि पावर 7 होना चाहिए. इट मीन्स दिस 3 here all 3 has imaginary part as positive and all 3 qualifies from primitive 7th root of unity. So we have set S. Now we have set S containing omega, omega square and omega cube. Okay? So this was all about understanding problem. Now let's move further. We have to find sigma. As you can see, we have to find sigma. S belongs to S and sigma T belongs to T, S plus T. Now since double summation is not in the syllabus, so JE can give this as a function and they can ask you. So it's fine. Actually this problem is nothing but double summation. So what I'll do, I'll make a particular T. I'll select a particular T. So as you can see, set T contains let's say Z. So when I fix T as Z, So the question boils down to sigma x plus z. Now there is no meaning of secant sigma because I have already fixed this bracket and I am fixing t value as z. Now s belongs to s. तो इसका क्या मतलब है? इसका मतलब अब s set s से ले जाएगा. And what is set s? It contains element omega, omega square and omega cube. So the question becomes omega plus z plus omega square plus z plus omega cube plus z. Similarly, now instead of t as z, if I would have taken z square, I would have got omega plus z square, omega square plus z square plus omega cube plus z square. And last way, if you have z cube is not there, so z4, omega plus z4, omega square plus z4 and omega cube plus z4. अब इसको if all of them you will add, what we are getting? By adding all of them, we are getting 3 times of omega plus omega square plus omega cube plus z square plus z4. And we need to find the real part of this. Okay, now we already know omega plus omega square plus omega cube real part will be minus half. And that's easy directly to see from the diagram because we know the real part of all this, because 1 plus omega square till omega 6 must be 0. The sum of all root of unity must be 0. Why? Because this is obvious, because z7 minus 1 is 0. So from theory of equation, the sum of root is coefficients of z6 divided by 1. So that's 0. So now you can see, so the real part of this, if I'll take real part on both sides, this must be 0. And since real part is distributive, so real part of w to w6 is equals minus 1. Now you know real part of w is omega, let's call it w, is same as w6 because they are conjugate. And omega square real part will be same as omega 5. Omega cube real part is same as omega 4 because they are conjugate pair. This you can prove in many ways. Since omega 7 is 1, so I can tell omega can be written as 1 by omega 6. And we also know omega bar is equal to 1. तो यहाँ से आप लिख सकते हो ओमेगा बार को 1 by omega. And what is 1 by omega? From this it is omega 6. तो देखो ओमेगा बार इज ओमेगा 6, सिमिलरली ओमेगा स्क्वायर बार इज ओमेगा 5 एंड सो. तो अब ये दैट इज इंटरेस्टिंग. इसका मतलब आई कैन राइट रियल पार्ट ऑफ w प्लस w स्क्वायर प्लस w क्यूब. आई एम इंटरचेंजेबली यूजिंग द वर्ड w and omega, so it's fine. Is same as real part of other thing 4, 5 and 6. So 2 times this equals minus 1. So that gives real part of this equals minus half. ठीक है, तो ये तो very obvious from the diagram था. So now I know this part is becoming minus half. Now what about z plus z square plus z4? Now again similarly you can see from here is the real part of z plus z square plus z cube plus z4 will be minus half from the same reasoning, because again this 4 guy has this conjugate over here. Okay, and sum of all roots is minus 1. तो यहाँ से what I am getting is z square plus z cube plus z4. This real part is going to be minus half. But z cube is not into picture. Okay, so what is real part of z cube? That I have to take up. So real part of z cube is not very difficult to find because e to the power we have already defined 2i pi by 3. अब इसका real part is cos of 2 pi by 3. Okay, that will be the real part of this because plus I sin 2 pi. Now what is cos of 2 pi by 3? It is in second quadrant, so it's 120 degrees, so that will be minus half. So that is interesting. The real part of z cube itself is minus half, so minus half will get cancelled. And real part of z square, z and z4, ये जो तीनों बच गया, that must add to 0. इसका मतलब this distance plus this distance is exactly this distance z4. अच्छा, so that makes this 0, and hence the answer for this we are getting is minus 3 by 2. Now according to the rituals of the question, they want the absolute values. Absolute value of minus 3 by 2 is 3 by 2, and it is expressed in a relative prime number m plus n. Just to make this question integer, usual JE fashion, m plus n is 5. So the answer for this last question was 5. I hope you must have enjoyed this problem, and especially the point was in most of the JE problem, understanding and comprehending the question itself is a challenging work. So make sure you do it properly. Okay, I'll recommend you, like you also solve problems on complex number which are more geometrical based like this, and the best source is previous year question paper, especially last 5 years question paper.